Hello, till last video we did discuss temperature dependent concentration terms. In this video we will discuss temperature independent concentration terms. Temperature independent concentration terms are percentage weight by weight, parts per million weight by weight, molality represented as small m, mole fraction of a compound sign, and these are all mass dependent. All these things I have discussed in the earlier videos. So first we'll take mass percentage, that is percentage weight by weight. So numerator refers to solute, denominator always refers to solution except in molality where it represents solvent. So first we will take percentage weight by weight. So here you can write weight of solute in gram divided by the weight of the solution in gram into 100. So it is multiplied with 100 because it is percent. So it is multiplied with 100. Parts per million, the same expression only we have. Only difference is into 10 to the power of 6. So parts per million weight by weight is equal to the weight of the solute in gram. Here also you have weight of the solute in gram. Weight of the solution in gram. Here also the weight of the solution in gram into 10 to the power of 6. So this is because per million. So when you have per million, you have to multiply with 10 to the power of 6. Percent means you have to multiply with 100. So we have one problem. This is an example problem. Neomycin aminoglycoside antibiotic cream contains 300 milligram of neomycin sulfate, the active ingredient, in 30 gram of ointment base. So here the solute is neomycin sulfate, the solution is ointment base. So percentage weight by weight is equal to weight of solute, that is neomycin sulfate in gram, divided by the weight of the solution, that is ointment base in gram. But here the weight of neomycin sulfate is given in milligram, but you have tried gram. So you convert milligram into gram, that is 1000 milligram is equal to 1 gram, 300 milligram is equal to 300 by 1000, that is equal to 300 into 10 to the power of minus 3 gram. So you substitute there. That is 300 into 10 to the power of minus 3 for neomycin sulfate, divided by the ointment base 30 gram into 100. So when you simplify, you will be getting 1% weight by weight. Next we will go to molality. So molality is denoted by the letter small m. It is defined by the number of moles of solute in per kg mass of solvent. So this is very important, in per kg mass of solvent. In earlier concentration terms we have solution and volume we have. Here you have per kg mass of solvent. So you can write m is equal to number of moles of solute divided by mass of the solvent in kilogram. Mass of the solvent here in kilogram. So you can write n by capital W in kilogram. Now n is number of moles. So this number of moles you can find out by dividing the weight of the solute by molecular weight. So that is W by m naught will give the number of moles of solute. So you can replace n by W by m naught. So you will get W by m naught into capital W in kilogram. So this is the expression, you can use it for doing problems based for molality. So unit of molality you can find out like this. So m is equal to number of moles divided by weight of the solvent. Number of moles, the unit is mole. Weight of the solvent, this is in kilogram. So mole per kilogram is the unit for molality. So we will do one problem. This is example problem. The molality of the solution containing 45 gram of glucose dissolved in 2 kilogram of water. Here the solute is glucose, the solvent is water. So here the weight of the solute is given, but molecular weight we have to find out. So the formula for glucose is C6H12O6. You have to add the atomic weight of all the elements. So first 6 carbon, so 6 into 12. 12 is the atomic weight of carbon. 12 hydrogen, so 12 into 1. 1 is the atomic weight of hydrogen. 6 oxygen, so 6 into 16. 16 is the atomic weight of oxygen. So when you add, you will be getting 180. So now you write the formula. M is equal to weight divided by molecular weight into weight of the solvent in kilogram. So weight of the solute here it is given as 45 gram. Molecular weight of the solute is 180. Into weight of the solvent here it is given as 2. So when you write 2 here, you will be getting 45 by 360, that is equal to 0.125 m, small m. We have some exercise problem. The first problem in the exercise, you have the molality of a solution containing 1.8 gram of glucose dissolved in 250 gram of water. This is given as choose the best answer. So you have glucose as the solute, Water is the solvent. Write the formula. M is equal to W divided by M naught into weight of the solvent in kilogram. But the weight of the solvent here it is given in gram. So you multiply the numerator by 1000. So you have the formula W into 1000 divided by M naught into weight of the solvent. So weight of the solute is given as 1.8 gram into 1000 divided by molecular weight. Here we have found out for glucose 180. So 180 into weight of the solvent in gram, 250 gram. So when you simplify, you will be getting 0.04 m. Molality. The next question number 42 in your book. Calculate the molality of a solution containing 7.5 gram of glycine. That is whose formula is NH2CH2COOH dissolved in 500 gram of water. Here the solute is glycine and the solvent is water. So solute glycine formula is given. You have to find out its molecular weight. So 1 nitrogen, so 14 plus 2 carbon, so 2 into 12 plus 2 oxygen, so 2 into 16 plus 5 hydrogen, so 5 into 1. So when you simplify, you will be getting 75. So now you write the formula. Molality is equal to W into 1000 because you have given the weight of the solvent in gram. So you multiply the numerator by 1000 divided by M naught into weight of the solvent in gram. That is equal to the weight of the solute is given as 7.5 into 1000 divided by molecular weight is given, we have found out as 75. Weight of the gram solvent in gram, that is nothing but 500 gram. So when you simplify, you will be getting 0.2 m. So compare molarity and molality. So molarity is denoted by the letter capital M. Molality is denoted by the letter small m. This molarity is temperature dependent because its formula is M is equal to number of moles divided by volume of the solution in liter. So it is mainly based on volume. So when volume changes as the temperature changes. So when you increase the temperature, volume also increases. So it is found to be temperature dependent. But molality is temperature independent because its formula is M is equal to number of moles divided by weight of the solvent in kilogram. The weight will not change with temperature. It remains the same. So as the temperature changes, weight will not change. So it will come under temperature independent. Unit for molarity is mole per liter. Unit for molality is mole per kilogram. It is found to be somewhat more inaccurate because it is dependent on temperature and it is dependent on volume. So as the temperature changes, volume also changes. So it is volume is in the denominator. So when the volume changes, when you find the concentration in different temperature, the molarity will be different. So it is found to be somewhat inaccurate since it is based on volume, but it is based on weight. So that the weight will not change with temperature. So it is found to be somewhat accurate. Which of the following concentration terms are independent of temperature? So when you take molality, it is independent of temperature. Molarity dependent on temperature. Mole fraction independent of temperature. So A and C are the correct answer. So these two are temperature independent. What is the molality of 10% weight by weight aqueous sodium hydroxide? So this 10% weight by weight, how to write? That is, numerator is for solute. Here solute is sodium hydroxide. Denominator is for solution. Solution is aqueous sodium hydroxide solution. So you can write 10 gram of solute in 100%. So it is 100 gram of the solution. So you can write 10 gram of sodium hydroxide is there in 100 gram of the solution. So always the solution is made with solute and solvent. So solute is sodium hydroxide 10 gram given. Solution is 100 gram. So the remaining will be the solvent weight. So solvent weight will be 90 gram. So now you have to find out molality. So M is equal to weight of the solute into 1000 divided by M naught into weight of the solvent in gram. Because since the weight is given in gram, you have to multiply the numerator by 1000. So substitute here. Weight of the solute is 10 gram. So into 1000 divided by 40 is the molecular weight because sodium hydroxide is the solute. Sodium 23, oxygen 16, hydrogen 1. When you add, you will be getting 40 is the molecular weight. Into 90 is the weight of the solvent. So when you simplify, you will be getting 2.777. Round it, when you round off, you will get 2.778. So A is the correct answer. Then we have mole fraction. So mole fraction is denoted by the letter psi. It is equal to the number of moles of the component divided by total number of moles of all the components present in the solution. So the solution is made up of solute and solvent. So solute you denote it as A, solvent you have it as B. So solute A mixed with solvent B to form solution. So you take the number of moles of solute as Na, number of moles of the solvent as Nb. So definitely the total number of moles of solution is Na plus Nb. Now you find out psi, that is a mole fraction of a component A. For each component you can find out. So the mole fraction of a component A, psi A, is equal to the number of moles of that component. Which component you have written? That component here. So Na divided by total number of moles of all the components. Here you have solute and solvent. So Na plus Nb. Similarly psi B you have to write only the numerator changes. Number of moles of that component Nb divided by Na Nb. So when you add psi A and psi B, you will be having like this. That is Na psi A is equal to, you write Na by Na plus Nb plus Nb divided by Na plus Nb. So when you simplify, it will be equal to 1. So the mole fraction of a component A and B will be equal to 1. Always it will be like this. So when you take the mole fraction of all the components in the solution, that will be equal to 1. We will do one problem. 0.5 mole of ethanol is mixed with 1.5 moles of water. The mole fraction of ethanol in the above solution is, so ethanol is given as solute, solvent is water. So you can find out for ethanol you have to find out. So psi A is equal to number of moles of ethanol divided by total number of moles of ethanol and water. So solute is ethanol. So number of moles of ethanol here it is given as 0.5 divided by number of moles of ethanol and water. So 0.5 plus 1.5, that is equal to 0.25. And similarly you can find out for psi, that is water, that is mole fraction of the component water. Psi B is equal to number of moles of water divided by total number of moles of ethanol and water. Number of moles of water is 1.5 divided by number of moles of ethanol is 0.5, water 1.5, that is equal to 0.75. So when you find out the total number of moles, total mole fraction of a solution, that is psi A plus psi B, then that will be equal to 0.25. Psi A is 0.25, this is 0.75. So when you add, that is equal to 1. So always the total mole fraction of a component in the solution will be equal to 1. Thank you for watching this video.